Today I'm going to do a brief review, and I do mean brief, of set builder notation and interval notation, and then we're going to talk about parent functions and their key features. Alright, for this set builder, it says x is less than negative or is less than 3. So in the set builder, it's this portion, x where x is less than 3. It is denoted by this line with the open circle for less than and an arrow to the left. Or x is greater than or equal to 6. Greater than the equal to part is why that's closed with a right arrow. And set builder, x where x is greater than or equal to 6. Alright, interval notation. You can look at this box. I'm going to sum it up. We can have x between any 2 points A and B with the parentheses. That means it is strictly between A and B, not including it. If you have the square brackets, it is including it. You can have a bracket on only one of them. Or you can have a infinity or negative infinity up to a number, including the number as in the square bracket, or not including it with the regular parenthesis. Alright, that sums up that. You can pause the video to look at those. It should also be in your notes. Again, you can pause the video, look at this. It's also in your notes. Alright, basic functions. Is it a function or not a function? I'm going to tell you all of these are a function, and they're all continuous. Alright, domain. There's an arrow going to the left and an arrow going to the right. Your domain is all real numbers. Your range is just 2. Your y-intercept, 0, 2. There is no relative minimum. There is no relative maximum. Okay, some people say there is not an absolute max or min. I will accept this answer because it is steady, it's constant. However, if it is constant, I will also accept if you say 2 is the min and 2 is the max, because that is true. It's never going above 2, it's never going below 2. It is just a function of 2. Okay? There are 4 more I'm going to add onto this. Positive, negative, increasing, and decreasing. After this, I will be shortening each of these words. Alright, this is positive, i.e. above the x-axis. So, this portion of the graph. Okay, that's just a little bit of enjoyment for me. Sorry. Anyway, the top portion of the graph, the function is above it through every real number, through the entire domain. So I'm going to write it as negative infinity to positive infinity. It is not negative. Increasing, it is not. It is constant. Again, constant, it's not decreasing. I'm going to go ahead and add these on the bottom here. Positive, negative, increasing, and decreasing. Alright, linear. It's a function. I'm going to use set builder notation for domain and range. The set of x values where x is in the real numbers. The arrow is going right, arrow is going left. Range, the arrow is going down and the arrow is going up. So it is the set of y where y is in all real numbers. There is no reason to use set builder notation rather than interval notation in this, other than because I can. Intercept, 0, 0. There's no min or max at all. It is continuous. All right. It is positive, again above the x-axis, after it passes the origin. 0 is not a positive number. It is not a negative number either. So, it is positive when x is greater than 0. It is negative when x is less than 0. The other way we can write this, so I'm going to write the word or, and this is the way I'll be using from here on out. It is positive from 0 to infinity. And it is negative from negative infinity to 0. It is increasing through the entire domain. It is not decreasing at all. Quadratic. Function is x squared. The domain. This arrow is going left. This arrow is going right. It is from negative infinity to positive infinity, or all real numbers. That is a terrible infinity sign. That looks a little better. The range is from 0, including it, to infinity. Y-intercept is at the origin, as most of these are. Alright, this one does have a relative minimum, and that is at 0. It does not have a max. It does also have an absolute minimum of 0. Here's the difference. If we have a line, okay? Anytime there is a turning, so this is going down, then it comes back up, we have a relative minimum. So this point here is a relative minimum. Likewise, this point where it comes down and comes back up is a relative minimum. However, the lowest this graph ever touches is at this dot. That is also an absolute minimum. Okay? That's the difference. Same thing for max, only, flipped upside down like that. Anywho, I wanted to make sure you understood the difference there. A quadratic is continuous. Positive, negative, increasing, decreasing. All right. Again, 0 is not positive or negative. So it is positive from negative infinity up to 0. Union with 0 to infinity. It is not negative. Increasing. It is going upwards when we are looking to the right. Always remember, you're reading this from left to right, okay? The easiest mistake to make, and again, it is a mistake, is to start at the origin and say, well, that's increasing. That's not increasing, y'all. You read from left to right. So it's decreasing down to the origin, and then it's increasing. Let me write this down, then I'll give you my example that I like. It's increasing as x is greater than 0, decreasing when x is less than 0. The example I like to use for this is the name Hannah. There's a word for this, I don't know what it's called, where it's spelled the same way forwards and backwards. If I asked you now what this said, you would say han. And if I asked you what this one said, you would say nah. That's correct. You read it from the left to the right. Han, nah. You do not say that this is nah. That's the way I want you to look at the graph. You read it from the left, then go to the right. If it's going down from left to right, like that, it is decreasing on that interval, and when it turns and comes up, it's increasing. Alright, just be very careful of that. Let me erase my hand real quick, and move on to cubic. It is a function. Domain is all real numbers. Range is all real numbers. Your y-intercept is 0, 0. You do not have a min or a max at all. It is continuous. Positive across all real numbers, the entire domain. Just kidding. I was thinking increasing. I apologize. Increasing across the entire domain. Positive. Because whenever x is greater than 0, so from 0 to infinity, it is negative from negative infinity up to 0. Decreasing. It's not. Square root. It is a function. The domain is from 0 inclusively to infinity. Likewise for the range. Your y-intercept is at 0, 0. Relative minimum is none. Remember, relative minimum is only when there's a turning point. This function does not have a turning point. It is just starting at the lowest point. So the absolute minimum is 0. No max. It is continuous. It is positive across the entire domain. That is to say, from 0 to infinity. It is not negative. It is increasing through the entire domain, so x is greater than 0. It is not decreasing. Alright, absolute value. It is a function. Domain, all reals, range, 0 to infinity, y-intercept, 0, 0, relative minimum, 0, no max, absolute minimum, again, lowest point, so 0, no max, continuous. It is positive from negative infinity to 0, union with 0 to infinity. Negative is not increasing, decreasing. It's increasing on the right side, decreasing from the left to the middle. So, increasing x greater than 0, decreasing x less than 0. Logarithmic and exponential. Alright, for these last two, I'm going to do them at the same time. That's because they are inverses of one another. An inverse means the domain and the range are flipped. They're their functions. The domain of a logarithmic is not including 0 to infinity. The range for exponential is not including 0 to infinity. The domain for exponential is all real numbers, and the range for logarithmic is all real numbers. Your y-intercept. Logarithmic does not have one. It's getting infinitely close to 0, but it does never reach it. So there is no y-intercept. The y-intercept for exponential occurs right here at 0, 1. I want to point something out to you. How the domain and range are flipped. Look right here at this x-intercept. It's at 1, 0. So your y-intercept for exponential is 0, 1. Your x-intercept for logarithmic is 1, 0. There's not a relative minimum or max. On exponential, there is not a relative minimum or maximum. If you was to write 0 for this, it does never reach 0 for absolute minimum, but it doesn't go any lower than 0. So you could write the absolute minimum as a number greater than 0, but it's infinitesimally greater than 0. If I said that correctly. It's infinitely close to 0, so I'm going to leave it as there's no absolute minimum. Because whatever number you can pick, I can pick a number smaller. Alright. It's just a special kind of not absolute min. They're both continuous. Alright. Positive, negative, increasing, decreasing. Positive, negative, increasing, and decreasing. Logarithmic is positive from 1 here to the right, so from 1 to infinity. It is never negative. Sorry. I was doing exponential. Logarithmic is negative from 0 to 1. Exponential is never negative. Exponential is positive through the entire domain, because remember, it never reaches that x-axis for 0. Okay? So, it is positive for all real numbers in your domain. Increasing is through the entire domain, so from 0 to infinity. Or, again, x greater than 0. It's not decreasing. Exponential, increasing through the entire thing. So, all real numbers. Alright, that's all I got for you today. I hope this made sense. Make sure if I ever ask you for the key features, or you are asked for the key features, that you have, or you know how to say all of these. There's 12 of them. 13 if you count function. I kind of don't. But anyway. Alright, have a good